All right, we're going to look at binomial radical expressions. So we're kind of going to be looking at adding and subtracting radicals. Okay, so if I have a to the nth root of x plus b to the nth root of x, that's going to equal quantity a plus b times the nth root of x. And then if I have a times the nth root of x minus b times the nth root of x, that's going to equal the quantity a minus b times the nth root of x. Now, there's a couple of key pieces here when we're looking at this. Okay, notice that my indexes are the same and my radicands are the same. That has to happen for this to be true. Okay, so you can't take the square root of 7 plus the square root of 5. That does not work. Okay, so if I want 3 square roots of 7 plus 2 square roots of 7, that gives me 5 square roots of 7 because they match up. So my first example here, I have 3 times the square root of 5x minus 2 times the square root of 5x. So what's going to happen here is this becomes 3 minus 2 times the square root of 5x, or the square root of 5x, or 1 times the square root of 5x. We won't write that. So now my second one, I have 6 x squared square roots of 7 plus 4x square roots of 5. Can I add these together? No. These are as simple as it gets. There's nothing I can do here to simplify that. Okay? Now the next one looks like, kind of like this last one. It looks like, hey, I can't do anything there. Okay? Now, before you say, hey, I can't add or subtract these, you actually need to work it out. Okay? You need to simplify these. Because the problem is 12, there is something that goes into 12 that I know the square root of. So I can actually break 12 up into 4 and 3. Well, I can break 75 up into 25 and 3. Okay? I know the square root of 4. That's 2. 2 square roots of 3. I know the square root of 25. That's 5 square roots of 3 minus the square root of 3. Well, now I have these all as radical 3. 2 square roots of 3 plus 5 square roots of 3 minus 3 square roots of 3. So that's going to give me 2 plus 5 minus 1 square roots of 3. Or 6 square roots of 3. So make sure you simplify before you say whether you can do it. Here we already simplified. There was nothing else I could do. Okay? Now we're going to talk about multiplying. Well, what happens if I'm multiplying a binomial there? Well, I'm going to multiply this out, double distribute, or FOIL, if you, whichever kind of way you want to talk about it. So I'm going to go 4 times 5 is 20. 4 times 4 square roots of 2 is going to give me 16 square roots of 2. 2 square roots of 2 times 5 is going to be plus 10 square roots of 2. And then 2 square roots of 2 times 4 square roots of 2 is going to give me 8 square roots of 4, right? Because square root of 2 times square root of 2 is the square root of 4. Now, a lot of times you're going to do this piece right here in your head. That's fine. I just wrote it out. So this piece here is going to give me 8 times 2, which is 16. So this is 20. These can combine plus 20 plus 26 square roots of 2 plus 16 is going to give me 36 plus 26 square roots of 2. A lot of you guys are going to jump, right from here to here. That's fine. Just understand that you want to make sure that you are doing the process. Okay, so the next one we're going to do the same thing. 3 times 5 is 15. 3 times the square root of 7 is 3 square roots of 7. Negative square root of 7 times 5 is negative 5 square roots of 7. And negative square root of 7 times negative 7 is negative square root of 49. Okay? So now we're going to simplify. I have 15 minus 2 square roots of 7 minus 7 is going to give me 8 minus 2 square roots of 7. There's my final answer. The next thing is this idea of conjugates. Well, what a conjugate is a different sign on the radical piece. So I'll have a positive and I will have a negative. So this one in our example here is 5 minus the square root of 7 times 5 plus the square root of 7. And we're going to look at what happens when we multiply those out, okay? So when I take this, I'm going to have 5 times 5 is 25. 5 times the square root of 7 is 5, square roots of 7. Negative square root of 7 times 5 is negative 5, square roots of 7. And then I have negative square root of 49. Well, notice here what's happening to my two radicals here in the middle. They cancel out. So I end up with 25 minus 7, or 18. So when we're multiplying by conjugates, it gets rid of that radical. And that's how we're going to have to do when we're rationalizing our denominator when we have a binomial. Okay, so I'm going to now multiply the top and bottom by the conjugate. Well, the conjugate is the difference in sign of my second radical. So I'm going to go 5 plus the square root of 2. And I'm going to go 5 square root of 5 times plus square root of 2. Okay, so now I just have to FOIL these out. Okay, so I'm going to do the bottom first. Square root of 5 times the square root of 5 is square root of 25. Square root of 5 times the square root of 2 is square root of 10. Minus the square root of 10. Minus the square root of 4. Okay, so I'm just multiplying these out. Square root of 5 times square root of 5 is square root of 25. Square root of 5 times square root of 2 is square root of 10. Negative square root of 2 times 5 is negative square roots of 10. Negative square root of 2 times square root of 2 is negative square roots of 4. Okay, so that's where I got all these numbers on the bottom. Okay, nice thing is this is going to simplify out really, really nice. Okay, now I'm going to take my top here. I have 3 square roots of 2 times square root of 5 gives me 3 square roots of 10 plus 3 square roots of 4. Square root of 3 square roots of 2 times square root of 2 is going to give me 3 square roots of 4. I'm not going to leave it like this. I'm going to simplify it. Okay, so on top I have 3 square roots of 10. Square root of 4 is 2, so this becomes 3 times 2. I'm doing it step by step. 5 square roots of 10 go away, minus 2 gives me 6 plus 3 square roots of 10 over 3. Okay, I'm not done yet because notice I have a 3 here, a 6, and a 3. Now, if I have a whole number in my denominator, I never ever divide into my radical. It's always the number in front. So this simplifies as 2 plus the square root of 10. There's my simplified answer. Okay, 3 goes into 6 twice, 3 goes into 3 once. Some people have a difficult time because they only want to cancel out this 3 here. Remember what this is. This breaks up into 6 over 3 plus 3 square roots of 10 over 3. Okay, so that's how I simplify that. So when you're doing this addition of radicals, remember your index and your radicand have to be the same. Okay, when you're multiplying out, you're going to use double distribute or FOIL, however you want to think about it, to multiply these out. That is the exact same way we have to rationalize the denominator also.